I got it. Hey, y'all. All right, we're back up in business. The applause should be for our earlier speakers, Blanca, Jonathan, Dave. Thank you so much. I'm the last talk of the evening. I'm also from Convoy, so I'm going to show a little bit at the end and tell you that you should come and work here. I've been at Convoy for about 7 months, and what I want you to take away from this talk, I'll tell you that up front, and I'll tell it to you, and I'll tell you it again, is that we basically managed to explore adopting Next.js into a mature set of code bases without increasing the DevOps burden on our individual teams. And that was something that's really important to us, given our stage of growth and just the sheer hell that on-call can be at this stage. But to give you a little bit more context, I work as the tech lead on the web platform team, which is a mighty team of one. It's just me right now. We're looking to grow, but we chartered this team in conjunction with Marcus. There's a mobile team as well. We saw that there was a great opportunity for us to start defining some core architecture that we would use across the various product pods in our company. We began this team at the beginning of the year, and I'm going to sort of tell you a story about how one of the first projects that we took on. So, a little bit more about Convoy. I know you've heard a lot about it already, but our R&D org is organized into pods. Pods are an organizational structure that we kind of cribbed from Spotify. The idea there is that you want to have a number of semi-autonomous teams within your company that are accountable to delivering a specific product. So we have pods like shipment success. It's all about making sure that live shipments do well. We have carrier and shipper experience, which are focused on other core stakeholders. And they tend to have like engineers, EMs, PMs, designers, data scientists, like everything you need to basically be a startup within the startup. This works really, really great for moving quickly and delivering on individual accountabilities. It's worked well for us, but one of the problems with this is that there is this concept called Conway's Law, not Convoy, but Conway. And the idea there is that, in a nutshell, it's that your architecture, your systems architecture, is ultimately going to be a reflection of your org chart. And if this is our org chart, you can imagine that we're going to have a bunch of individual front-end web apps. And they're all hosted on different host names. They're all slightly different, and this is a real pain in the ass because we want to normalize. We want to provide some common guidance. We want things to be consistent for all the new developers we're hiring. And we're at least all on React, but there's a lot of different things floating around out there. So one of the first things that we did to try to decide the path forward for greenfield apps. So I'll back up and say, there's a long-term goal to converge these, but right now we have new pods spinning up every quarter, and we have new apps spinning up every quarter that we need to provide some guidance to. So the way that we tackled that problem was to begin go on a little listening tour, ask all the devs, the EMs, the PMs, everybody that's involved, what's working, what's not. And a couple clear themes emerged from those conversations. The first is that we're spending way too much time tweaking Webpack configs. Spending way too much time optimizing, everything. Every time we want to add a third-party dependency, especially now that we've adopted TypeScript, it's a real pain. We spend way too much time sort of futzing with Webpack and optimizing the front-end performance of these ever-growing apps. Another thing that the PMs brought up this year that I found really interesting, and it's definitely something that corresponds to our phase of growth, is that we're beginning to do more content marketing. And this means that there are more dynamic screens that we want to host sort of in the logged out experience in our apps. And for that, if we're going to put effort into it and we're going to try to drive traffic to those pages, then we should focus on SEO. And SEO usually means server rendering. So all of these little things pointed to Next as being perhaps the correct path forward. I imagine that most of you have heard of Next.js. It's something that's gained a lot of traction in the React community over the past 2 years. It's basically a batteries included framework for React on the web. It's actually quite a bit like Expo for React Native. It's slightly more opinionated than vanilla React, and the key thing that it provides is server rendering right out of the box. I don't know if any of you were in the industry about 10 years ago when Node hit the scene, but it was a day of rejoicing because everybody said, oh, we can run the same JavaScript we run in the browser right on the server, and server rendering is going to be free and easy. And it absolutely wasn't. It was a hell for many years, and the browsers continued to get better. We continue to build static single-page apps. But I have to say, I think that we're finally there. I think that we're finally at the point where server rendering can be made easy, and it's Next. And it really, really makes it simple to deliver a fully rendered page from the server directly to Googlebot or directly to your customers. And what's nice about that is that Googlebot really likes it. Googlebot is smart enough nowadays to run your client-side JavaScript and actually index the page, but it is absolutely penalizing you as it does it, because it tracks something called time to first meaningful paint, which is basically when does the DOM seem to stabilize for the user. And that really heavily influences your position on search rankings. So even though you can be indexed without server rendering, you really still want it if you are serious about SEO. So Next was a good candidate for solving that problem. And one of the lesser benefits of it that I really loved was that it took away all the Webpack config hell that we were in. They have just about 200 integrations like with other common libraries out there, like all the CSS and JS with Apollo, all these different things that we're using. And they made it really easy to basically get out of the business of screwing around with build configs. So this was a really compelling pitch to the tech leads on the individual product pods. But the one thing that I consistently heard from EMs and the tech leads was, what burden is this going to place on our DevOps? And it's an interesting question. It has some context to it, but just to define what that actually means, we're talking about things that can wake you up in the middle of the night when they crash. If you think about it, server rendering, oh, and I have this too. I don't know if anybody saw this, but this haunts me still. We are coming from an architecture where we have just a simple, static, single-page app for each of these products. I think this is fairly familiar to most of you, but I'll run through it real quickly. Like Convoy in 2018 and earlier basically was using Webpack to take all the JavaScript files. Webpack would emit a JavaScript bundle or a couple of JavaScript bundles, depending on how optimized we were. It would emit an HTML file that was mostly empty, just a single root element, and we'd throw that all on S3. And then when somebody came to one of our host names, say like shipper.convoy.com, from their browser, they make a request and it would hit CloudFront, which is Amazon's content delivery network, AWS solution. And CloudFront would basically say, oh, I don't have that. I'm going to reach out to S3, and it would serve that index HTML that has no content in it, but it just points at the script files. The browser gets that. It loads all the JavaScript, megabytes and megabytes of JavaScript, and then it binds to the route, it renders the page, and it takes about 2 seconds. But, you know, it's only the first time, right? So it's not a big deal. What's nice about this architecture, beyond the fact that, well, the build is fairly stable and it's a well-known architecture, so that's nice. But another thing about it is that basically if your deploy doesn't fail, your uptime is the uptime of AWS. Like, there are no services in here that you have to manage directly. You're basically up if CloudFront and S3 are up. And they're up pretty much most of the time, not always. So DevOps burden is effectively zero. The teams that I was speaking to had no, it never happened. Like, it was very rarely, maybe not never, but it was very rarely Amazon's fault. And so everybody was generally happy with this world, and we needed to preserve it. Next is a little bit more complicated than that, because as I was saying, it does server rendering. Server rendering has to happen in a service. So we have to think about services now. The build process for Next looks a little bit similar to the static world, but we're taking all of our source and throwing it into Next and Next build, which will actually use Webpack under the hood. It does some nice things for you, like it splits your bundles per page, and it does tree shaking and all the happy things that you want for performance. But what it emits are a couple of bundles for each of your pages, and then it emits a server rendering service as a JavaScript file. And then you have to wrap that up, or what we do is we wrap that up in Docker into a single container, and then we push that to the Elastic Container Registry on AWS. It's like S3 for Docker containers. And then when a user's browser hits our Next.js service, it'll go through CloudFront, it'll hit an AWS application load balancer, and then it ultimately communicates to one of the many containers we have running Next, and Next will look at the route, it'll render the HTML, and it'll return it to the user. This is great because it's better for performance, but the problem with it is that containers are still machines, They're machines that we have to manage. They will go down. They do go down. There's all kinds of problems. I'm not going to enumerate all the problems of like DevOps, but like as soon as you have your own service to manage, you are in a world of pain, and it will page you in the middle of the night at some point. We didn't want that. Our goal really, if we wanted to experiment with Next as the path forward for Convoy, was to find a way to introduce it and make it as robust as a static web app, which was our baseline. That was difficult. We sat on that for a little bit. We were thinking, is there any way that we can square this circle and figure out a way to experiment with Next without upsetting the on-call designees for all these individual teams? Because ultimately, web platform doesn't own on-call. It's the individual teams who choose to adopt what we're proposing. What we had was a key insight, which was that Next is, it does this interesting thing. It's all in the realm of performance. But what Next does is when you make your first request, it will render the first page on the server, and you get a fully hydrated page of markup. Crawlers love it, users love it, it's fast. But as soon as it binds the script to that DOM and React sort of rehydrates the page, all further navigation happens as though it was a static client-side app. So Next is server rendered initially, and then it's fully static. So our goal actually was basically to make Next.js just a static web app. We thought, can we just get rid of the server-side rendering component and leverage all the other benefits of Next, but also make it just run as a static web app that renders entirely on the client? What's interesting about it is that there have been a lot of other people who have been asking for this. The Next team has been working on it, but ultimately it only took a couple of small changes to Next that we were able to make. We're still working off of a fork right now. It's not actually upstreamed yet because the Next team is also working on it. So it's something that's likely to land fairly soon. But we have a slightly different build in order to support this scenario. This is what the new build looks like, but the only relevant portion is this portion towards the bottom where instead of just building a container, a Docker container that has a server rendering service, the Next build is also emitting a client-side rendering bundle and that single, very slim HTML file that just has a root div in it that's completely empty. And we still throw that up on S3 like we did with our client-side app. The real magic comes in when we start working with some features in CloudFront called origin groups. So what we do is we set up S3 as a peer, as a sort of a secondary fallback to the Amazon load balancer, the application load balancer in our CloudFront origin group. And the happy path remains the same. If the server rendering service is up, browser hits CloudFront, CloudFront routes to the ALB routes to a container, Next will render the page and return it, and you can sort of see my feeble attempt to show you a hydrated markup file. That's what we want. That's the 3 nines case. But let's say that the containers are taking a little too long to respond, or maybe that the ALB actually went down in US West 2, which happens occasionally. What will happen is that CloudFront will hit the ALB or hit the container. It'll get some kind of 500 series error, and when that happens, or when a timeout happens, it'll mark the ALB and containers as unhealthy, and then it will fall back to serving off of S3. And S3 is configured just as we did with the static web apps. Basically return the same index.html file for every route, and that file basically just has an empty root node and some script tags that point to the static version of the Next app. So when that gets returned to the browser, it's a flash of blank page, but as soon as it initializes, it'll bind to the route and will render the app as though it was a static web app, and you're off to the races. The only impact on the users is like 200 to 500 milliseconds of additional latency. It is a bit of a problem for search engine crawlers, but it's not a big enough problem to page you in the middle of the night. It's like Sev 2, not Sev 1. So effectively, by making Next export into just a strict client-side app, we were able to mitigate that DevOps burden and bring it down to a level that was of acceptable risk where we were able to experiment with it. What was nice about that is that we discovered that Next is actually really robust. We rolled this out with an app at the beginning of the year. It has not actually failed over in production yet because Next is actually quite robust. So that's really nice. Next has also simplified our build tooling significantly. Still haven't had to write a Webpack config, and I love not being in the business of doing that. And it's worked out so well. I know. I would clap at that too. We've rolled this out to another app this quarter, and it's pretty clearly now the path forward. And it was something that we couldn't have done if we didn't really respect the fact that on-call is a really big deal, and each team has every right to protect themselves against any additional operational risk. So it forced us to find a creative solution, and that's what we did. And by basically exporting the Next app as a static single-page app, you can work around it yourself. This is the point of the evening where we wrap up, and I give you one more shameless plug about the fact that web platform is still just me, and I could really use your help. Anybody who has like front-end ops interest or finds this kind of work interesting, please reach out to me. We are really serious about beefing up our efforts on building out front-end architecture here at Convoy, and we're also really excited to speak to anybody who cares about front-end development from a product perspective, because there's a ton of opportunity. Also, I'm going to ask you to follow me on Twitter. My manager over here has 10 times the number of followers that I do, but I have way better cat content. So please go out there, also JavaScript, and email me. All right.
When you've the server-side render page, it has loaded into the browser,
yep.
And the user then tries to enter something into an input field before React has rehydrated the page. What do you do then?
So that's I'll repeat the question, which is that if the server render page has been returned to the browser, but React is not bound to the page yet, and the user manages to put focus into an input field and type something, what happens? The answer is that React itself, when it goes to rehydrate, will do the right thing, and it will respect the input, and it will raise the appropriate events and flush that through the rendering flow of React and the reconciliation. So if you had an input that was designed to maybe restrict input, what would happen is that those characters would be there for a second, and then the validation would occur, and maybe it would strip out letters from a currency field or something. But in reality, what's interesting about studies about perceived performance is that as long as you have painted something within 800 milliseconds, most people are not going to interact with it up to 2 seconds, and you have a pretty broad window by which to go and like load the rest of your script and bind to it. So that's a pretty rare case. It happens more on mobile clients. One of the neat things, again, I'm just going to plug Next a little bit more because I really love how they built it. If you're using CSS and JS solutions like Style Components, Glamorous, or Emotion, they pretty much all do the right thing, and they basically will extract the critical CSS, or what's viewed as like the CSS that's necessary to render the first page, and they'll put it in the head of the file. So as soon as the markup is finished loading, you have a fully painted, like rendered screen, and it really makes a huge difference in perceived performance.
What's the performance you saw that went better from changing from the old one that you have to Next.js?
It's a great question. I can't give you those numbers because, oh, I'm sorry, and I'll repeat the question. I always screw that up. The question was, what was the performance gain that we actually witnessed from a legacy app to Next? We don't actually have an apples-to-apples comparison there because we rolled this out with a new greenfield app that didn't exist on the old platform. So we can't say yet. But as we start rolling this out with other side-by-side with existing applications, we'll have better insight. I just wish I could answer your question. I can't. Yep.
What were the challenges that you foresee when moving a legacy app to Next, right? Because something you need to do differently for Next.
Yeah, it's a great question. The question was, what are the challenges we foresee moving a legacy application to Next? What's nice about Next is that it maintains a very limited surface area that you actually interact with. It's fundamentally a pages directory that sort of influences the router. So one of the key pain points is if you're on React router, you kind of have to divorce yourself from it and adopt Next router, which is a little less sophisticated. I would say that's the main pain point. The only other way that Next really interacts with your app is that it has a static method that it calls on your top level page called getInitialProps. But you don't actually need to provide that. You can have legacy pages sort of ported over that don't server render well, but will still operate perfectly fine as soon as the page is loaded. And that's the approach that we've been experimenting with our next app, or the next app that we're implementing next upon, which is a legacy app. The idea is that we want to limit the amount of refactoring that goes into adopting new technology, and it hasn't been a problem in practice yet, other than just getting rid of some of the fancier things we were doing with React Router, which ultimately were confusing for a lot of engineers as well, because having subroutes and a lot of routing that's keyed off of query strings and things is not, it's something that we can do without.
I have another
Oh,
one.
yep.
Too many questions here. What viewport size does Next use when it's rendering from the server? Does that make sense? Is there a mobile version when you're saying that there's CSS that's put into the head? Is it a mobile version or is it a desktop version that then is, how does that work?
That's a great question. The question is, what does Next do when it's server rendering regarding viewport size, specifically around like maybe the CSS, the critical CSS that gets inlined? That's actually on a per library basis as far as CSS and JS goes, like when you're managing your CSS and JavaScript. I'm pretty certain, but I'm 99% sure that what Emotion does is that it actually runs the media queries based on some viewport data that actually gets sent up by most browsers as a header. And it will find the critical CSS for that, but it's still couched in a media query. But alternatively, like, you can't actually access the DOM when you are doing that server rendering. I guess you do have to make some changes, and if you're accessing specific viewport measurements or any DOM nodes and getting like offset top or offset width, you can't do that during server rendering. That does break, and that's, I guess that's a bit of a limitation because it's not a true DOM that you're rendering. You're actually still working exclusively in the React Virtual DOM.
Did you consider the framework Gatsby, and if not, what advantages did Next have that made you move in that direction?
Great question. The question was, did we consider Gatsby alongside Next, and what were the pros and cons, or why did we decide Next? Gatsby is another great framework. I love Gatsby. I think what they're doing, especially connecting static site rendering to various data backends using GraphQL, is like it's a beautiful thing because GraphQL is also so intuitive for that kind of work. Gatsby, though, is mostly focused on rendering and producing statically rendered content for an enumerated set of pages. And so Gatsby, where Gatsby falls short and Next sort of picks up the baton, is when you have routes like ops.convoy.com/shipments/someID. Gatsby can't power that because when you're reading parameters from the route, Gatsby can't do anything other than give you an empty page that has to have the router bind at that time. So it's no different than a statically rendered single page app. Whereas Next is able to basically look at the route, and it's able to look at your headers, look at the cookies. It's able to represent the user on the back end as it makes a request to APIs, and it really returns fully server rendered content at any point in your app's lifecycle. So you can just click around a Next app, do a Command R, and do a hard refresh, and you should ideally see the same thing if you've sort of abided by the rules of server-side rendering. All right.